Hi friends! So today we will go to the next part of our vector, which is position vector. Okay, so let's check our previous homework first. So this is the answer for part A and part B. Okay, let's look back at question 13 first. We recap again. AM, we need to find AM, which is A to M. Okay, before even you need to find AM, you have to find AB first, because we know that M is midpoint, right? Here stated that M is the midpoint of AB. So if you find AB, after you have found your AB, then AM will be half of it. That's why I find my AB first. A to B is A to O, and O to B. Okay, so A to O is negative A because it's anti-direction, it's this way. It's going this way. So if it's going this way, means that it's not A anymore, it's negative A. That's why it's negative A here. And B plus with the B, because O to B. So after you found your AB, you find AM, because AM is half of the AB, half times AB. So your AB is your negative A plus B. That's why it's negative A plus B, half. And you expand it, you will get this answer. Okay, and as for OM, O goes to M is O go to A go to M. Or if you go the other way around, OBBM also can. Okay, but I'm showing this working lah. OM is O to A, and then A to M. OA is already a AM is the one from A. After that, this part here, simplify, become half A, and then half B, bring it down. Okay, so that's the answer for question 13. Alright, so position vector, what is this about? Okay, it's a vector which describes the location of a point, just as simple as that. Describe location of a point. Okay, but to describe the location of a point, it's all relative to origin. Okay, go back to your Cartesian plan. This is a 2D Cartesian plan which you have an x-axis and y-axis. Okay, the location of any of the point, okay, it will be related back to the origin. Okay, I give you example. Okay, if I say position vector of A, okay, so it means that O goes to A. Okay, later I'll give you an example from here. Okay, position vector of A is O to A. So if I ask, if I say position vector of B, then it must be related back to your origin, so it's relative to origin, so it's OB. So position vector of P, then OP. Position vector of Q, then OQ. Okay, just as simple as that. Okay, to understand it even better using this Cartesian plan, okay, you have a y-axis, x-axis. Okay, this is a 2D Cartesian plan. Okay, you have a location of any of the point. Okay, for example, if you have a position at this point over here, let's say this point is A lah, and your origin is here, right? Okay, let's say your position A, a coordinate of the A, okay, you know about coordinate already. Coordinate of A here, as you can see, is 5, 2. Okay, you see this 1, 2, 3, 4, 5. I'm not gonna write the 5 here and 2 here. I get you have too many numbers here, you will get confused. Okay, so your A is coordinate of 5, 2. Okay, so the coordinate of 5, 2, right, is actually, it's relative to your origin, the point of your origin, O here, the center of O here. Okay, what do I mean by that? Okay, so if I have a direction from O goes to A, right? Okay, it's actually goes this way first. Okay, from O to go to A, right? You go this way first, which is 5 step, and then it goes up 2 steps, isn't it? That is why your 5 is here and your 2 is here, because it's 5 to the right and 2 up. That's why your point of A, your coordinate of A is 5, 2. Actually, your position of A is at a coordinate of 5, 2. Am I right? So it's actually relative to your O, relative to your origin here, which 5, 2. It goes 5 to the right and goes up 2. Okay? So when we say position vector of A, okay, we're gonna write this in column vector form. Okay, so if I say OA, our position vector of A is 5, 2. It's the same as coordinate, isn't it? Coordinate, you just write bracket and then 5, 2. Position vector, you write x on the top, y at the bottom. Okay, this is O, A. Okay, O to A. Position vector of A is 5, 2 like this. Okay, so if I have another coordinate, let's say B. Okay, this is my B. So my B, okay, my position vector, I'm not talking about coordinate. I know coordinate, you know how to see already. You know how to see coordinate. So if I say position vector of B, what is the position vector of B? Position vector of B is 2, 4. Okay, positive 2, positive 4 relative to origin of O, this one. Okay, because you are going to the right 2 units and going up 4 units. Okay, and it's the same as your coordinate, isn't it? So basically, your coordinate is also your position. Okay, position of A is 5, 2. So if I say position vector of A, okay, this is what you're gonna write. Position vector of B, this is what you're gonna write. Okay, so this is example 1. So if I have O, let's say to P, your X is on the top, your Y is at the bottom. Okay, so this is what we call position vector. Alright, and you must be related to origin. Now let's look at example 2. Right, example 2, we have 2 coordinates here, coordinate A, coordinate B. Okay, so if I were to ask you, what is the position vector of A? Then you have to write O to A. Okay, so position vector of A is O to A, which is actually the same as your coordinate 1, 3, because this position is X and Y, right? So you just write 1 on the top and 3 at the bottom. This is your OA. Okay, and if they ask you position vector of B, what do you think? OB, OB, which is 5, 2. Okay, and now my question here, what is my AB? Okay, A to B is not position vector. Position vector show you the position only. Okay, and it's always relative to O. Okay, what I mean by relative by O again is you can see that position vector is always starting from O. You see, like this one, OA, OB, right? Okay, like example 1, we have OA, OB, you see this? It's all starting from O. So position vector is always start from O1, always start from O. Okay, so if AB is not position vector, but it tells you the direction from A to B. Okay, what is the direction from A goes to B? From A goes to B, So is it to the right, to the left, up, down? Which one? Okay, you have to see. Okay, A to B. Okay, I've given you the diagram here. It's easier for you to see. Okay, if got diagram, it's easier to see because A to B, you see how many steps to the right? 1, 2, 3, 4. 4 steps to the right, and go down 1 means -1. So you know that AB is 4, -1. Okay, let's say if you're not given this diagram, okay, what you're gonna do? Okay, you have another method of doing this. Okay, you have another method of doing this. How? Okay, let's see. AB is also from A goes to O first and plus with O goes to B. Meaning to say that A goes to B means A goes to O first and O goes to B. Right? So A goes to O, we already have OA. So AO is a negative. Okay, we have learned this in previous lesson. When we add negative in a vector, means that it's anti-direction. Okay, so this will be negative bracket column vector 1, 3. Or if you put -1, -3, it's the same. It's the same thing. Okay, so I will just stick to putting negative in front of the column vector. Plus with OB. OB, we already have 5, 2. Okay, and then we found -1 plus 5 is 4. And -3 plus with the 2 is -1. Okay, you see that? It's the same as this, right? We know that A to B is 4, -1. If you're doing this method, also can. If you want to choose this method, also can. But this method, you have to look at the diagram. Okay, another method, okay, by the way, this is called vector method. This is vector method. Okay, vector method. Another way of doing this is by looking at the coordinate. Okay, I'm going to teach you how to look at the coordinate. This is coordinate of X. This is coordinate of X. Okay, 1 goes to 5 means you plus 4. 4. And then you look at 3 goes to 2. Okay, it means that it go down one step, so minus 1. Okay, just do that. Or you can just use this coordinate. If you are going A to B, this coordinate you minus it. 5 minus 1, so 4. 2 minus 3, negative 1. Okay, you can just do that by just looking at the coordinate. Okay, I'm teaching you this method when you are not given any diagram. Okay, so to find AB, just like this, alright? Okay, how about BA? Okay, let's look at BA. BA, okay lah, you already know that it's anti-direction of this, right? 4, negative 1 means if you have BA, it's negative 4, positive 1. Okay, you anti-direction means you add a negative 4, this one negative become positive 1, right? Okay, what if you are doing in a vector method? Vector method, BA is B to O plus O to A. Okay, how do I get this answer? I use vector method. So BO is negative of 5, 2. Negative because of anti-direction. OB, this is BO. Plus with OA, OA is 1, 3. Then you will get the same answer as this. Okay, so as simple as that. Now we proceed to our next example, example 3. Now that we have parallelogram, okay, ABCD is parallelogram. Okay, this ABCD is parallelogram. I draw it out here so that you can see, you can visualize it better. Okay, if we have a parallelogram, we have 2 pairs of parallel line. This is one of the pair, and this is another one of the pair. Okay, if I ask you to find a position vector of A, okay, this is position vector of A. Okay, it's the same as the coordinate, which is this. Okay, and position vector of B. Okay, position vector of C, and position vector of D. Okay, can you do that now? Okay, you try. Okay, is it same with mine? Okay, so after this session, I hope you understand more about position vector. Okay, it's the same as your coordinate because it's relative to your O. Okay, now, what is my BC? Okay, let's try BC. Okay, without looking at the diagram, try using vector method how to find BC. Using vector method. All of you here use vector method. Don't use the method that I teach you just now. I mean, if have in the exam, of course you can do that. This one we are practicing on vector. Okay, we are practicing on using vector method. So please do it together with me. Okay, so BO is anti-direction of this. So I add a negative here. Plus OC is 4, 1. So I get 3 and negative 2. Okay, my BC is 3, negative 2. Okay, as you can see here, BC, 3 steps to the right, 2 steps down. That's why it's 3, negative 2. Okay, how about AD? You look at AD, AD. Okay, try using vector method. A to O plus O to D. I want you to find it out using vector method. Okay, I read properly. O, O, D. AO plus OD. Okay, so A to O is negative of this. Okay, so here I will get negative become plus. Positive 2 plus 1 is 3. So it's negative 2. Okay, and you look back at this AD. Okay, let's look back at this. B to C is 3 and then go down, right? Minus 2. A to D also the same. 3 and then negative 2. Okay, you can see BC is actually equals to AD. Okay, we can see that here BC is the same as AD, which is 3, negative 2, right? Why? You see this, they are parallel. If parallel and same length, then they will be the same. Okay, so BC is equals to AD, which is this. Okay, now, try do AB and DC. A to B and D to C, AB is AO plus OB. So negative 2, 1 plus OB. Okay, so AB is 3, 2. Okay, negative become plus, positive 2 plus 1 is 3, negative 1 plus 3 is 2 at the bottom. So this is your AB. And DC is DO plus OC. So DO is negative of this OD, plus OC. So plus with 4, 1. So you get 3 and also 2. So from here, we can also see that AB, direction of A to B is D to C, which is 3, 2. Okay, because they are parallel. Okay, let's look at AB. AB is to the right 3, unit go up 2. Same goes to DC, 3, 2. Okay, so I'm using vector method to find my BC, AD, AB, and DC. But in your exam, if the question did not say use vector method, okay, if you need to find the answer, you can just look at the diagram if you are given diagram. If you are not given any diagram, you just look at the coordinate also okay. Alright, that's for example 3. Okay, let's go to try it. Let's look at try 11. You are not given any diagram, no diagram here. Okay, let's see. P, Q, and T are 3 points such that, okay, so we know that this is our OP. Position vector of P is 0, 1. And your position vector of Q is OQ, which is 4, negative 1. And your position vector of T is 2, 4. Okay, this is your position vector. Okay, express PQ as a column vector. So, part A. P goes to Q. Okay, P goes to Q. If you can just look at the this coordinate also can. Okay, if not, I'm using the vector method, which is PO equals to PO plus OQ. Your PO is your negative of OP plus with OQ, which is 4, negative 1. So when I plus, I get 4, I get negative 2. Okay, so this is my column vector. If you are looking at it in terms of a coordinate, okay, you can just look at this. This is another method of doing. I'm teaching you the method. Okay. What you do is you look at this 0 to 4. 0 to 4 is basically go to the right 4 units. Okay, so this will be your X. And if you are looking at 1 to negative 1, okay, it goes down 2 units, so it's minus 2. Okay, or you can think of it like this. 4 minus 0 is 4. And then negative 1 minus 1. You get negative 2. Therefore, P goes to Q is 4, negative 2. Okay, because XX with YY ma, you look at XX over Y. You must look at P to Q lah. Then you have to use the coordinate of Q minus the P. Q here goes to P. If Q to P, then P you minus Q. Okay, this is another method. But I'm teaching position vector now, so I'm using vector method to teach you, okay? Part B, use a vector method to find the coordinate of R if PQRT is a parallelogram. Okay, we have 3 points here, PQT, but we don't have R. But they say here PQRT is parallelogram. Okay, so we roughly draft out the parallelogram, okay? just a draft. Okay, let's say P, Q, R, T. Okay, and your P is 0, 1, your Q, okay, and your R you don't know, your T is 2, 4. Okay, what you have is only the coordinates, and you note that it's parallelogram, means that the length here and here same, and here parallel with TR. PQ is parallel with TR. Okay, they have the same vector. PQ you already have 4, negative 2. If here is 4, negative 2, then here is also 4, negative 2. Okay, so if we are not using vector method, right? Okay, this is the method that I'm going to teach you before I use a vector method. Okay, you know that 2, 4 is this coordinate. You want to go to R with a position, with a vector of 4, negative 2. Okay, meaning to say that your x from 2, right? You will go to the right 4 units. So you plus 4 goes to 4 units to the right, so you will get 6. Okay, which is 2 plus 4, which is 6. Okay, and then look at the y. Your y is 4 for the position vector position of t, and it goes 2 to the go down. Okay, y is go down. Negative 2 means go down. Okay, so 4 go down 2 units, so 4 minus 2 you will get 2. So your coordinate of r is 6, 2, which is 4 minus 2. So basically this one, you plus with the vector, you will get r. Okay, this is how you understand if using coordinate. But now this question is asking us to use vector method. Okay, to use vector method, we want to find coordinate of r. And we know that coordinate of r is the position vector of r. Okay, so position vector of r is also, okay, OR is also O goes to T plus T goes to R. Okay, O goes to T, T goes to R. Okay, why do I use TR? Because we know TR is 4, negative 2. How I know it's 4, negative 2? Because parallel ma. If parallel means this vector same this vector. Okay, same vector. So OT is 2, 4. Okay, and your vector TR is 4, negative 2. And you plus them, you get the same thing. Okay, so your position vector of r is 6, 2, which means that your coordinate of r is 6, 2. Okay, so that's the answer. Of course, this is easier to do, but if you want to show in vector method, this is how you do lah. Okay, that's for try 11. Okay, now let's go to exercise 8.3. Okay, I want you to do some of this as your homework. Okay, question 1, I think you can do it all. Okay, you have to find position vector of P, position vector of Q. So it means that you have to find, I do a few questions here lah. Number 1A, let's say you want to find OP. Okay, it's 2, 5. So 2, 5. You want to find OQ, it's the same as this, so it's 4, 6. And then P goes to Q is PO plus OQ. PO is negative of this, plus OQ is 4, 6. So you get 2, 1. Okay, just as simple as that. Okay, so let's let you do part B and B, C, D. Okay, I've done part A for you already, and B, C, D you do. Question 2. Okay, question 2 also I will teach you. Okay, question 2 I teach you. It is given that A is the 0.35. Okay, this is 35 means that OA is 35. And the vector AB is 4, 7. Find the coordinate of B. Coordinate of B basically is O to B. OB is OA plus AB. O goes to A first and then A goes to B. Okay. So you can see this is your first and end. Okay, it starts from O goes to B, end at B. So O go to A first and then A goes to B. Okay, so OA you already have, which is 3, 5, and AB you already have, which is 4, 7. So you plus become 7, 12. So your coordinate of B, you write in coordinate forms is 7, 12. Just like that. Okay? Okay, question 3. I think this one you can do. Okay, I think this one you can do. Okay, you try to do by yourself. Okay, that's all from me today. So your homework is 1, 2, 3. Please send everything from the example from your notes onwards until here in the assignment post. Okay, see you guys next lesson. Bye.